Advances in 3D printing hardware, software, and material science have made stereolithography, or SLA, technology more affordable and accessible, enabling businesses to change the way they approach prototyping, testing, and production. SLA 3D printed parts are being deployed in every industry as end-use products, industrial replacement parts, manufacturing aids, tooling, and more. Their smooth surface finish and light and tight tolerances make them ideal for use in multi-part assemblies, consumer-grade products, or final design review parts. Joining us today is Cole Durbin, Technical Program Manager from Formlabs, to give us a demonstration of the Form 4, the latest 3D SLA printer that Formlabs is offering. So thank you for joining us today, Cole.
Thanks for having me. Great to chat
So
with
why
you.
don't you tell me a little bit about your role there at Formlabs and about this Form 4?
Sure. Yeah. So my role here is technical program manager. And so for the past 3.5 years or so, I've been leading the development of Form 4. This is a big hardware, software program that we've been doing here. It's kind of our flagship SLA product. And so my job here is to make sure we ship the right product as fast as possible. And so, we're very pleased with the Form 4 and happy to finally have it on the market and have people using it and telling us what they think. So it's been a lot of fun.
Well, that's terrific. So my colleague Rihanna Begg had been at Hanover,
Mhm.
and she got to see a little demonstration. And so it seems that the fourth generation 3D printer has really incredible speeds. So can you tell me a little bit about the technology that enables the Form 4, and then of course the Form 4B, and tell us how that differentiates to achieve such speeds?
Sure. So low force display is what we call the core of the technology behind Form 4. And that's really what generates these speeds. So compared to the Form 3, most prints can be 2 to 5 times faster, depending on what you're printing, what material you're using. And we accomplish that through that low force display, sort of optical stack. And I've actually got a couple of those components here, so we can kind of show you live. But at the bottom of the printer, we have our backlight unit. And this is a super high-powered collimated light source. It's an LED array with a collimating lens on top that generates really consistent, uniform light at high power to the print plane. This allows you to cure resin very quickly, to print very quickly. One big difference from the Form 3 is we're now area curing each layer instead of using a laser to raster the shape of the layer. So that means that print speed is much less dependent now upon geometry, upon the size of your print. Each layer is roughly the same time, especially in the curing perspective, as compared to Form 3. So that's a great advancement. Moving up, we get to the LPU, the light processing unit, and this is an LCD, but it's actually a lot more than just an LCD. It contains our heating, our resin temperature sensing, but also our texture surface, our texture film on top. And that allows airflow between the top of the LCD and the bottom of the resin tank, which allows really low force, consistent peels. Peel is another part of the print process, happens every layer. And so allowing that to be consistent and fast also unlocks very fast print speed. So that's kind of the core of our low force display technology that allows you to print really quickly.
And can you tell us a little bit about the difference between the Form 4 and the Form 4B?
Yeah, so the Form 4B is targeted to our dental and medical users. And the hardware is actually very similar, but the Form 4B is sort of a license system that allows you to print with our biocompatible and dental resins. And that's sort of a whole new ecosystem on top of the Form 4 printer targeted for those users specifically.
Why don't we talk about the maintenance and the operational procedures, since you just showed us how you take that, it's very modular.
Sure.
So what's recommended to ensure consistent high-speed performance and longevity of this printer?
Yeah, I would say we designed the printer to sort of do this on its own as much as we can. And one part of that is a multi-point factory calibration that sort of sets users up for success. So we have many tests that we run, calibrations we run to ensure that the machine works very well out of the box and works well for the life of the printer. But there is maintenance you have to do, as you mentioned. So I talked about that low force display optical stack, and making sure that the texture film is clear of sort of dust and debris is one thing that's important to do sort of every few prints. And then keeping the build platform clear of debris, making sure that after every print that's totally clean. But again, we have systems on the printer that are sort of designed to help users either remember to do this or tell them when they haven't and prevent damage to the machine. So the mixer in the tank, as well as the force sensor inside the printer, can actually detect debris in the tank or on the build platform prior to starting a print and warn the user that they need to take care of that. Many of our competitor LCD printers would actually just damage the printer if you left debris on the build platform. So that's something that we designed sort of carefully for. And the other side to this is when things do happen, components degrade, accidents happen, we really intentionally design the printer to be user serviceable. So the two side panels of the printer and the back panel are removable with just a few screws, and almost every subsystem is user replaceable with those access panels. So design is to be very serviceable so we can increase uptime, because even with lots of preventative maintenance, things can happen, and we want people to get their printers up and working as quickly as possible. So user serviceability, we have a long list of replaceable components that our services team can help with. So that was another key consideration on that front.
Are there any special tools that have to be used to clean the parts and to maintain?
Yeah, so to maintain the printer, we actually built into the printer what we call a tool caddy. And this is actually interesting because it's SLS 3D printed on our Fuse 1 printers in production. So this is sort of a production 3D printed component. And this contains some of the things you need to maintain the printer, notably 2 Allen keys. With these 2 Allen keys, you can remove or replace all of the components on the printer that you might need to. And then also contains what we call parallelism shins. And these are basically 4 plastic pieces that can be used to auto level the build platform to the LCD display. And that's a user routine I didn't mention, but that's another one that if you're seeing poor early layer adhesion to the build platform, or you just really want to get fine-tuned performance out of your printer, the user can go run that routine, which is built onto our UI, and the printer sort of walks you through that. But again, that's another factory calibration that's done out of the box, and most people might never need to touch. But I do like this component that we ship that's sort of 3D printed. It's a testament to us standing by our word that you can manufacture with 3D printing in high volume production.
Right.